Hi, everyone. I'd like to welcome you to the Nature Conservancy's Lunch and Learn. We're really excited. This month, we have Aaron Wilson with us. He is an assistant professor and extension educator at The Ohio State University, and he's going to be talking about the agricultural impacts of this year's drought, talking a little bit about agroforestry and providing insights on how we can prepare for climate events in the future. What we will do for this presentation. Aaron will be presenting for about 20 minutes, and then at that time, we will take questions. You could come off mute at the end or put your questions in chat, and we are recording this. So with that, I would like to welcome Aaron, and thank you very much, Aaron.
Yeah, thank you, Stephanie. Can you hear me okay?
You sound great.
All right, thanks. Yeah, welcome everybody. Or if you're watching this on YouTube, thank you for checking this out. Certainly, we had an interesting drought situation across much of Ohio this past year. And we wanted to unpack that a little bit, put that into a longer time scale sort of context, and at least offer some words or get us thinking about how we build some resilience to these types of events. And so I'm bringing some weather and climate information. You all are experts in different areas of either agriculture, natural resources, or elsewhere that can really help us bring those expertise together to come up with ways of becoming more resilient to these challenges moving into the future. All right, so historical drought in Ohio. We have droughts in Ohio. This is always part of our natural cycle and things that we experience. And really, over the course of history, Ohio gets dry, every 2 to 5 years generally. But one of the indicators that we used to use, at least from the mid 1960s through to the year 2000, was called the Palmer Drought Severity Index. If you want to look at more details, it's basically temperature, moisture, evaporation, and some soil moisture modeling that goes into this. And it's a really good indicator, index for long-term drought conditions. And I'm showing you a time series of the Palmer Drought Severity Index since 1895 for the state of Ohio. Anywhere you see yellow, that's dry. Those are drought periods. Green, these are wet periods. And you look at the time series, and you can see we had these, prolonged clusters of droughts occurring in the 1930s, also in the 50s, and then early to mid 60s as well. Since then, over the last 40 years, droughts have been comparatively shorter in length and really lesser magnitude if you're looking at the Palmer drought. One thing to keep in mind is that this single index is good for long-term drought. You're looking at 4, 5, 6 month time scales, not droughts that are really intense over shorter periods of time. And the one thing that we've seen of late are really intense short drought periods even in a much wetter environment. So as precipitation is increased, we still get droughts, but they tend to be really intense, mostly focused on that summer, late fall, into the fall time frame in terms of when those occur. So there has been a transition in drought across the region. Now, when we talk about drought, drought is not strictly objective. It's a mix of both objective and subjective elements. And when you see things like the U.S. Drought Monitor map, which I'll show you on the next slide, you've probably seen a lot of it in the media lately, certainly this year. It's trying to encompass all different types of drought on the map. So we could talk about precipitation deficits, compared to normal. That's meteorological drought. Agriculture is an area that gets usually hit first and hit hardest in drought. Then hydrologic drought, you're thinking about your streams, your reservoirs, your lakes. Ecological are ecosystems, prairies, wildlife, and then socioeconomic drought as well, the economic impacts that we still don't have a handle on those full economic impacts from this past season. Um, so this is the latest U.S. Drought Monitor map from last week. We'll have another release tomorrow with the Thanksgiving holiday this week. It'll come a day early. Typically, it's released at 8:30 on Thursday mornings. Since the year 2000, when this was adopted, it takes more of a hybrid approach. So you take these physical indicators and indices, well over 150 of different types of quantities that we look at the statistics and how they're changing based on precipitation and different impacts at the surface. And then we bring together the local based expertise and impacts that also get incorporated. And so it again is not just strictly objective, but it has a subjective element to it. But that local based expertise is really important. And here in Ohio, This is coordinated through the State Climate Office. So my role is as the State Drought Coordinator. We offer our suggestions each week to the national author at one of the federal agencies that draws that map. But our team is comprised of National Weather Service offices that cover Ohio, all counties, some federal partners, state agencies, other state climate offices around the region, and then our university partners and researchers as well. And the kind of the key phrase to think about this is it's a convergence of evidence. So those physical indicators are all happening and showing different points along the water cycle, and also on different drought severity levels. So whether that's soil moisture or groundwater levels or evaporative demand or how much atmospheric demand there is on that surface moisture, types of drought, different lengths and time scales, and droughts don't look the same in summer as they do in wintertime. You can have really big, severe precipitation deficits in the winter, and still things look okay at the surface. And so there's a lot of things to consider, and it's really this convergence of evidence approach that gets us to the maps each week. The impacts alone won't change the maps. Again, it's both objective and subjective when you look at conditions across the state. So obviously we had a pretty significant event this year with 2024, and I'll step through the milestones. Back on June 11th, we didn't have any category of drought across the state of Ohio. These different drought categories that you'll see starts out abnormally dry, and then the first actual drought category is in moderate drought conditions. So June 11th, no categories. 2 weeks later, all of the yellow you see here, these were areas that were abnormally dry. We just came off a 10-day period of 90-degree weather across the state. D1 was introduced around the Cleveland area, Southwest Ohio, and Southeast Ohio. A few weeks later, mid-July, D2 or severe drought was introduced to parts of Pickaway County and southeastern Ohio, and really it just started to ramp up from there. By August 13th, this was the first time that we'd seen D3 or extreme drought introduced into the state since August of 2012, another big drought year across the state. And then for the first time in the last 24 years, and since the inception of this method, D4 or exceptional drought was introduced there in Meigs and Athens County in southeastern Ohio. This is not current. It says current, but it's September 24th. This was the maximum drought coverage that we had across the state. And you can see a little more than 12% of the state in D4 or that worst category, over 35% in the D3, D4. And of course, a lot of our FSA relief credit programs are uh, automatically activated at D3 or D4 categories. So quite a few states, or sorry, quite a few counties across the area became eligible for those relief programs. And then total drought area was about fifth most. The only years where we had a little bit more coverage was in 2002 and 2012. But as you can see, there's not a lot of yellow and white on the map, so not a lot of the state was left to even be in those drought categories. And we continue to meet at the EMA and ODA on a monthly basis right now as those conditions continue. We are slowly improving those conditions across the region. They're shrinking. Conditions have improved. We've seen emergence. We've seen good wheat emergence, greening. Our grass obviously came back. And so with cooler temperatures, you see less evaporation and more of that water can soak into the soils. We've not seen a big yet jump up in our deeper soil moisture. So we're still lacking considerable amount of moisture across the state, upwards of a foot of rainfall deficits now still in eastern Ohio. And our stream flows and rivers have not really returned even back to historical median levels at this point. We're still waiting for that. And of course, the soil has to continue to moisten up for that to happen. Now, as far as impacts go, this was a highly impactful drought this year, especially across eastern and southeastern Ohio. Uh, for a while, a lot of the focus was on pasture and livestock. At maximum, we had 93% of Ohio's pastures in poor to very poor conditions this year. And producers we're feeding obviously winter stocks and alternative feeds very early in the season. Later on, when there was, a little bit of Hurricane Helene moisture came in, and then colder freezing temperatures, a lot of concerns over toxicity as well. The hay resource directory from the ODA has been available, so folks have been able to find alternatives out there, but they're having to do so because, we got very short first hay cutting and virtually no second, third, or fourth, with some minor regrowth really late, really in late October, early part of this month, that allowed some additional grazing in some of those areas. The other thing that's been really impactful was water from a water situation. Just a lot of water hauling in southeastern Ohio. Groundwater resources are fairly scarce compared to many other parts of the state, like Northwest Ohio. And thousands, 60, 70,000 gallons of water were being transported by some of the livestock producers each month just to keep livestock watered there across the region. That doesn't mean that row crops were not impacted. Certainly, harvest activities began about 2 to 3 weeks early this year. Very rapid dry down. We had soybean moisture in the 6%, 7% range across southern and eastern Ohio, 11% corn moisture. And these fields were really primed for a lot of fires and very dusty conditions, even in northwest Ohio. Later in the season, we had a lot of dusty harvest conditions there. But fall harvest fire risk was significant. A lot of multi acres, big fires across Pickaway, Madison, other areas of southeastern Ohio as well. In highly variable yield reports, and it'll be one of my lessons that I'll show you in a second. Had this type of drought occurred, say in the 80s or 90s, with genetics and other things, impacts to row crops would probably have been greater than they were. We've got a lot of crops now that do more with less water as part of a drought strategy, and it seems to have been the case here in Ohio this year as well. Specialty crop impacts, early fruit and nut abandonment on trees in southeastern Ohio. Um, there was some extensive insect pressure early on vegetable crops, but there were other areas that didn't see very much pest impacts at all, which were beneficial actually to some of our pumpkins and specialty crops. But in southeast Ohio, some fall tourist attractions were impacted, poor rootstock where irrigation wasn't taking place, and other impacts like loss of Christmas tree seedlings on some of the uh, uh, those farms in southern and southeastern Ohio as well, where they seeded, put seedlings in May. For instance, a former colleague had over 650 seedlings that were lost this summer because of the drought conditions. Again, impacts on hydrology, creeks completely dry, low ponds, dry private wells, springs didn't run across southeastern Ohio, and even some of our major inflows to our reservoirs in southeastern or southwest Ohio ran dry. So we were at winter pools in a lot of our lakes and Army Corps of Engineer controlled reservoirs before October. And then we came back and had our seventh driest October on record in the state of Ohio. So that just continued to sort of exacerbate conditions, especially deeper water in those streams and reservoirs. Forests and fire impacts. We saw trees that continue to turn rapidly or abandon leaves across the state. So risk for wildland fire and grassland fires was really significant as well. Even up to last week, numerous reports of grassland fires, long burning fuels that were available. We did have a burn ban that lasted in most of September and dropped in October. But some of those long burning fuels were available long after that, with some big fires where departments in southeastern Ohio were not able to really keep up with some of those intense fires across Wayne and Selinsky and other areas of southeastern Ohio. And then the landscape, fall color changes, dead grass, a lot of perennials, trees. When it comes to a lot of the perennials and trees, it's likely that we'll see some canopy thinning even next year and tree death based on the drought conditions that we've had this year, and perennials that won't come back, that are actually dead, didn't just go into dormancy, but were dead because of the very dry conditions that we've seen. So we're likely again to see some of these impacts from this year's drought moving forward over the next couple of years. So my takeaways, and from this year in the drought conditions, this has been one of Ohio's, I should say one of Ohio's most impactful droughts. We've had other drought years: 2007, 2012, 12, 07, 02, 99, 88. These are some of the years recently that we think of big droughts. The timing, the fact that it started in June was probably good for row crops. largely unlike 88, which started in March, and we had over a 50% crop loss in 88 compared to this year. We were able to get crops out of the ground, emerging and growing pretty well. But it really, the pastures, some of those wild grassland areas really took a hit this year. And we've had and experienced all types of droughts this year, for meteorological and agriculture, hydro, ecological, and socioeconomical as well. Both the ag and water resources have been challenged, but I think it really shows comparatively across the country how robust our water resources are. Not that we should take advantage of those. And one thing that I like to point out to folks is yes, we are water rich. Even in the middle of drought, we've got a lot more water than most Western states can imagine. But the demand on that water, those water resources, is ever increasing from development, agricultural land transition, major companies moving in for those water resources. And as population is expected to increase and the demand for that water increases, the potential risk from these droughts can continue to increase as well. We do have networks out there of drought early warning systems, and those do work. In extension, we were able to get the word out early in late May, early June that conditions looked favorable for these drought conditions, and that we were likely to see those conditions continue throughout the upcoming summer and growing season. If you want to check out some more resources that we have through Extension, I've provided a link there and a QR code if you're interested. Um, so to transition a little bit to putting us into sort of a longer timescale perspective, I want to pull in just a little bit of information from the latest National Climate Assessment. One thing that we know is that we are trending warmer, and around the Great Lakes, there's sort of an amplification of warming, but there's a seasonal difference in that warming as well, where our winters and springs are getting warmer, a lot faster than during the summertime. A lot of our summertime heating in Ohio is driven by overnight temperatures that are warming, not daytime highs. And you can have some offsetting stress conditions there because you're not getting as hot during the day during the summer, but you are seeing warmer temperatures at night, so overall warmer average temperatures, which also affects the amount of evaporation that you're seeing in terms of driving that soil moisture from the surface. When you look at overall our winter trends, spring trends, and rainfall, they are increasing, and annual we're increasing as well. But again, over the last, say, 40 to 50 years since 1970, we've seen an offset in those seasons, and I'll show you that just in a moment. Even though we're not seeing as many 100-degree days, where we hit at least 90 degrees, we are seeing longer, more frequent, more intense heat waves across much of the U.S. That's what the figures on the right are showing you, the trend between 89 and 2018 there at the bottom. And this can lead to biophysical impacts, uh, and raising production inputs. And when we think about adaptation strategies, and there's a lot of them, obviously we can do a whole day, right, on different types of strategies. We may refer to them as climate smart or different conservation techniques, thinking about how we can limit some of those impacts out there. From the precipitation perspective, we know our winters are getting a lot wetter. We know our springs are getting a lot wetter in Ohio. That's what these two figures are showing. But when it comes to summertime, those trends are flat to even negative in many parts of Ohio. And so what we're getting a condition where we see more rainfall, we see more cooler season rain, we see more annual runoff, but more runoff in winter and spring, and less runoff, lower flows during the summertime and fall. And of course, that can impact water availability. It impacts our riparian areas. And in the spring and summer, we're seeing more intense rainfall events that often lead to more stream bank erosion, sediments in the water, and can really be detrimental to those ecosystems as well. And we're really being challenged from that seasonal change in precip perspective. Now, again, there's a lot of things that we can talk about, and we're already at the 20-minute mark, so I'm going to keep this brief. But, one of the techniques, obviously, thinking about agroforestry practices as a climate smart technique, and climate smart agriculture. We know, we generally accept that climate smart ag should increase productivity, enhance resilience, and also, reduce emissions, direct emissions that can continue to contribute to some of these issues. And agroforestry is one of those practices and different techniques that many of you I know are aware of, from alley cropping to riparian forest buffers, windbreaks, and the like. But I wanted to carry this drought theme forward with agroforestry practices. And this information, really good assessments being conducted by the state climatologist Trent Ford in Illinois and his students. They've looked at several of these and thinking about how does alley cropping, for instance, check off the climate smart program. Increasing productivity, soil fertility, environmental impacts improvements, climate mitigation improvements, but also where are those trade-offs or limitations? And I think when it comes to things like water and nutrient competition or water management and management complexity, of course, that's a trade-off, but there are a lot of good benefits from agroforestry. And thinking about this as just as an example of the many different techniques, I really like this graph here, and you can see um, the paper reference there in the bottom left, but comparing monoculture and agroforestry, and I'm going to highlight two here. From a microclimate perspective, a lot of the monoculture is exposed to extremes where agroforestry practices can help limit those extremes and reduce heat stress and improve even animal welfare where those things are conducted. So thinking about a year like this with hot conditions and very dry conditions. The other one clearly is in water management, right? Really high demand from a monocultural perspective. Agroforestry really lowers that evapotranspiration, the evaporation of that moisture, increases the availability of water storage. Yes, there's trade-offs with competition there as well, but overall there's a reduced water stress and increased water use efficiency potential. And in a year like 2024, this is just kind of an example where agroforestry can really shine to help mitigate some of those potential. So I'll just take a couple minutes here just to round us out to say, okay, we've started to improve on our drought. Where are we heading as a quick little forecast and projection into the winter season? Over the last 30 days, southern Ohio is really starting to moisten up now. You can see compared to normal on the right-hand side, many of those counties in southern Ohio are wetter than average, but the bulk of the state is still running below average. So things may look greener. The surface may be responding pretty well, in terms of pasture regrowth and grass coming back. But we're still running those deficits. And until we really get to normal to above normal precip, we're going to continue to hold that drought potential for next season. That's the one thing I want us to kind of think about here. So even going back 60 days or 90 days, the bulk of the state is still drier than average, indicated by these percent of normal precipitation values here. And in fact, I think I already mentioned this. On the right-hand side, just focusing on that figure, if you go back to May 28th, Guernsey County, Noble County, Morgan County, these are areas that are running about a foot to even upwards of 15 inches below average over this period. And you combine that with 22 inches of water lost through evaporation in the summertime, or potential loss in the summertime. That's why we had these exceptional drought conditions there in that area. But things are easing a bit, and certainly, again, because it's not just the physical indicators, but it's the impacts at the lower level. Our soil moistures are starting to improve. That's what these figures are showing, especially in the left here, soil moisture change over the last month. We're starting to see more soil moisture come back, and we're starting to see some of our rivers and streams respond. Although, as you can see, orange and red dots mean that generally we're still below historical flows throughout the state. So we're on a slow journey of from this exceptional drought of 2024. This week looks pretty moist, unfortunately, for Thanksgiving holiday. I think it also looks white for some of the counties in west central and north central Ohio with a little bit of snowfall. Projecting out through the first week or two of December, overall, it looks pretty dry and very cold. This is likely to be the coldest start to December, the first week, maybe 2 weeks of December, the coldest 2 week December period that we've seen in at least a decade. So very cold conditions, a lot of 20s for highs next week, a lot of overnight lows in the teens. So just get ready for that. But as we have a weak La Nina this winter, we are expecting at least a trend toward wetter than average conditions, especially January, February, and March. This is what we need to really refill and recharge the soils across the state. If we don't see that, then my concern, again, going into March and April, are much earlier drought onset next season across the entire state. So we'll continue to monitor that and hopefully avoid the worst of drought conditions that we saw, exemplified by this very nice photo from our Eastern Agricultural Research Center uh, Christine Gelly in Noble County took this shot. So with that, I'll stop there, Stephanie, and I'll turn it back over to you.
Okay, thanks, Erin. Thanks for that great presentation. I am willing to take some questions from anybody who has anything that they would like for Erin to clarify. And you're welcome to come off mute to do that. Any questions from any of our participants? Okay, well, it doesn't seem like we have any questions there, and must mean you did a really great presentation. We appreciate it. I really appreciate you talking about not only the conditions of our soils, but the conditions of our groundwater and how that impacts not only this year, but the future. So really informative presentation. We thank you for your time, and I hope everyone has a wonderful day.